Hello students, today we will be learning about the metabolism of tryptophan. In this, tryptophan is being metabolized into form different products. So in this reactions, the tryptophan is being converted into N-formyl kynurenine in the presence of tryptophan pyrrolate. Then and then oxygen is being added to it. The N-formyl kynurenine is being changed into kynurenine in the presence of formamidase, and the what is being converted into HCO negative. Then this kynurenine is being changed to 3-hydroxykynurenine in the presence of kynurenine hydroxylase, and this kynurenine is being changed into kynurenate and alanine and ethranolate. Then this 3-hydroxykynurenine is converted into the presence of ammonia into xanthrogenate, and then this hydroxyquinone is being changed into 3-hydroxyethranolate in the presence of xanthorene, and this 3-hydroxyethranolate is being changed in the presence of 3-hydroxyethranolated oxidase, iron I consist and oxygen is there, into 2-amino 3-carboxymuconates semialdehyde. This 2-amino 3-carboxymuconate semialdehyde changes into three. It shows three products in the presence of different enzymes. The first one is the picolinate carboxylase enzyme, and it forms picolinate. Second, decarboxylase enzyme, and it forms 2-amino muconate semialdehyde. And the third reaction is simultaneously spontaneous, so it changes into quinolate. Now this quinolate changes into nicotinamide mononucleotide in the presence of QPRT, and this PRPP changes into PPR, that is pyrophosphate, and then this mononucleotide changes into NAD plus and NADP plus. The second decarboxylase enzyme changes into 2-amino muconate semialdehyde, and in the presence of aldehyde dehydrogenase changes into 2-amino muconate, and NAD plus changes into NADH plus H plus. This 2-amino muconate changes into glutaryl CoA and then to acetyl CoA. The first reaction, it is also known as kynurenine pathway. This occurs in liver, leading to oxidation of tryptophan and synthesis of tryptophan of NAD plus and NADP plus. Step 1 is tryptophan pyrrolase. Oxygenase cleaves the 5-membered ring of indole nucleus tryptophan to produce N-formyl kynurenine. This enzyme is metabolic protein consists of an iron porphyrin ring. The second is formamidase hydrolysis. Formyl kynurenine liberates formate which enters the 1-carbon pool. Kynurenine undergoes an DPH-dependent hydroxylation to get 3-hydroxykynurenine. Kynurenine, a paradoxical phosphate dependent enzyme, acts on the 3-hydroxykynurenine and splits off alanine. Tryptophan is glucogenic because alanine is a good precursor for glucose. This enzyme kynurenine is very sensitive to vitamin B6 deficiency. Due to lack of this enzyme, this reaction is blocked and 3-hydroxykynurenine is diverted to form xanthionate. Elevated excretion of xanthionate serve as an indication of B6 deficiency. This step leads to formation of 3-hydroxyethranolate. 3-hydroxyethranolate is cleaved by an oxidase ferrous dependent to form an unstable intermediate 2-amino 3-carboxymuconate semialdehyde. This undergoes three stages. The third stage, it undergoes continuous chicalization to form quinolate for NAD+ synthesis. Picolinate carboxylase enzyme decarboxylates the intermediate which produces picolinate. The intermediate undergo decarboxylation catalyzed by amino carboxyl semialdehyde. It produces 2-amino muconate semialdehyde. That enters semialdehyde is converted to 2-amino muconate in presence of enzyme aldehyde dehydrogenase. The aminomuconate is a series of reactions involving reduction, deamination, and decarboxylation is converted to glutaryl CoA and finally to acetyl CoA. The NAD+ pathway quinolate undergoes decarboxylation and is converted to nucleotide mononucleotide by the presence of the enzyme QPRT, quinolate carboxyl transferase, which leads to formation of NAD+ and NADP+. Serotonin pathway, it is a neurotransmitter synthesis from tryptophan. In mammal, largest amount of serotonin It is synthesized in intestinal cells. Tryptophan is post-hydroxylated at fifth carbon by tryptophan hydroxylase. This enzyme requires tetrahydrobiopterin as a cofactor. 5-hydroxy tryptophan is decarboxylated by aromatic amino acid decarboxylase. Thank you.